you are going to be expected as a core skill to work out the formula of ionic compounds. So here I go through all the ones that I expect you to know, and then loads and loads of examples working you through how to do lots of examples. I just said that. If you want more examples, if you want more practice, if you want loads and loads of questions, because that's really the only way you're going to get better, you can go and get my workbook over on my website, which has loads of stuff in there for you. Here is a list of all the formula that I would expect you to know. I would expect you to easily be able to recall all of these. You can see that I've got a list for you here. You can either copy this down from the video, or you can go to my website and get the workbook which has all of these in. You can see I've made a video with flashcards for you with these same ions in, and again you can get the flashcards available from my website. But please, please, please learn these. The rest of this video is learning how to apply these. So if you want to use this video successfully, you're going to need to have this list in front of you as we go through all of the examples so that you can practice working out ionic formula. You can think of this a little bit like doing a really big logic puzzle. What you want to get is an equal number of positives to an equal number of negatives, so that there's like nothing left over. There's no overall charge, no positive charge or negative charge. Now sometimes it's going to be easy and things are going to go together in a 1-to-1 ratio. Sometimes it's not going to be so easy because something's going to be 2 positive and something else is going to be 1 negative. So what you need to do is fill in this extra gap with another negative. So we have 1 block of the positive thing and 2 blocks of the negative thing. Now sometimes this is going to get really, really complicated when we have something that is, say, 3 positive and something that is 2 negative. At this point, the best thing for you to do at the moment is just keep playing around until you manage to work out that it basically needs to add up to 6. Now the actual putting things together isn't too complicated. It's just writing down the formulas when you're trying to work out something like ammonium sulfate or ammonium hydrogen carbonate. These things look complicated and these things look nasty, but with practice you will be fine, and that is what you need to do. Practice shed loads. So silver iodide. Here we have silver, here we have iodide. You can see that is A plus and I minus, positive and minus in a 1-to-1 ratio, so it's just going to be AgI. Magnesium iodide, so here we have magnesium 2 plus and iodide 1 minus, Mg2 plus I minus. Now we can think of the magnesium in like a little block with 2 prongs poking out of it, and the iodine in 1 block with 1 prong poking out of it, pointing the opposite way, one way positive and one way negative. We need all of the little prongs, all the little blocks to be completely full up, and you can see we can do that by having 2 iodines for 1 magnesium, so it's going to be MgI2. Lithium iodide, Li, I minus, Li plus, I minus, that is Lii. Capitals and small letters are really important. Lead 2 iodide, lead 2 iodide, Pb2 plus, I minus. Again, because we have 2 positives, we need 2 negatives, so it's going to be PbI2. Copper 2 iodide, copper 2, iodide is 1 minus, Cu2 plus, I minus. We're going to need 2 minuses for the 2 pos, so it's going to be Cui2. Iron 2 bromide, so iron 2 is here, bromide is here, so that is Fe2 plus, Br minus. That is going to give us FeBr2, because we need 2 bromines with a negative charge to cancel out the 2 plus of the iron 2. Iron 3 bromide, iron 3 bromide up here. We have Fe3 plus Br minus. Now we have 3 positives, we are going to need 3 negatives to cancel that out. So that is going to give us FeBr3. Barium bromide, barium is here, bromine is here. Ba2 plus Br minus. So we need 2 minuses to cancel out 2 positives. So we have BaBr2. Strontium bromide, Sr2 plus B minus. Again, we are going to need 2 minuses. That is SrBr2. Strontium chloride, Sr2 plus Cl minus, which would give us SrCl2. Copper 2 chloride, Cu2 plus Cl minus, which will give us CuCl2. Iron 2 chloride, Fe2 plus Cl minus. We need 2 chlorines, so that is FeCl2. Do not get confused by that 2 in the name, it does not mean we have 2 ions. Calcium chloride, chlorine, Ca2 plus Cl minus, CaCl2. Lithium chloride, Li plus Cl minus, LiCl. Barium chloride, Ba2 plus Cl minus, BaCl2. Sodium oxide, oxide, Na plus O2. So now we have 2 negatives and only 1 positive, so we need double the number of positives. So we get Na2O. Potassium oxide, K plus and O2 minus, we're going to get K2O. Zinc oxide, Zn2 plus O2 minus, ZnO. Aluminium oxide, oxygen, we have Al3 plus O2 minus. This is quite tricky, well, one of the trickier ones to work out. The easiest thing is just to cross multiply. So have an Al and take this number up here, so that is going to be 2, and then O and take this number up here, so that is going to be 3. If we actually look at the number of positive charges, we have 3 plus times 2, which equals 6 plus, and then 2 minus times 3, which equals 6 minus, so we can see that it equals it out overall. Strontium oxide, Sr2 plus O2 minus, SrO. Copper 1 oxide, Cu plus O2 minus, Cu2O. Copper 2 oxide, Cu2 plus O2 minus, CuO. Iron 2 oxide, Fe2 plus O2 minus, FeO. Iron 3 oxide, Fe3 plus O2 minus. Again, the easiest way to do this is just to cross multiply, so we get Fe2O3. Chromium 3 oxide, Cr3 plus O2 minus, Cr2O3. Iron 2 carbonate, iron 2 carbonate, Fe2 plus CO3 2 minus, 2 positives 2 minus, they just go together in a 1-to-1 ratio. So it is FeCO3. Ammonium carbonate. So we have ammonium, we have carbonate, NH4 plus CO3 2 minus. Now you can see we only have 1 positive charge and 2 negative charges, so we are going to need another positive charge to cancel that out, which is going to give us NH4 2 CO3. Copper 2 carbonate, copper 2 carbonate, Cu2 plus CO3 2 minus. These are both 2 positive, so we can have them in a 1-to-1 ratio, CuCO3. Lead 2 carbonate, lead 2 carbonate, Pb2 plus CO3 2 minus, again in a 1-to-1 ratio, so it's just PbCO3. Sodium carbonate, sodium carbonate, Na plus CO3 2 minus. We're going to need another sodium, so it's Na2CO3 2 minus. Magnesium carbonate, magnesium carbonate, Mg2 plus CO3 2 minus, again 1-to-1 ratio, so we can write them down. Iron 2 carbonate, iron 2 carbonate, Fe2 plus CO3 2 minus, 1-to-1 ratio, so it is FeCO3. Barium carbonate, barium carbonate, Ba2 plus CO3 2 minus, nice 1-to-1 ratio there, so we can write them down. Potassium hydrogen carbonate, potassium hydrogen carbonate, potassium hydrogen carbonate, both have 1 negative charge, so they can go together in a 1-to-1 ratio. Strontium hydrogen carbonate, strontium hydrogen carbonate, so that is Sr2 plus HCO3 minus. We are going to need 2 minuses to cancel out negative charge, so it's going to be strontium HCO3 2. Lithium hydrogen carbonate, lithium hydrogen carbonate, lithium HCO3 minus. These can go in a 1-to-1 ratio, lithium hydrogen carbonate. Ammonium hydrogen carbonate, ammonium hydrogen carbonate, NH4 plus HCO3 minus. 1 positive, 1 negative charge, so we can say NH4 HCO3. Sodium hydrogen carbonate, sodium hydrogen carbonate, Na plus HCO3 minus, 1-to-1 ratio. Magnesium hydrogen carbonate, magnesium hydrogen carbonates, Mg2 plus HCO3 minus. We are going to need 2 hydrogen carbonates for every 1 magnesium. So we're going to get magnesium, hydrogen carbonates. Ammonium sulfide. Ammonium sulfide. NH4 plus S2 minus. So we're going to need another NH4 plus. So that will give us NH4 2S. Iron 2 sulfide. Iron 2 sulfide, Fe2 plus S2 minus. That gives us FeS. Aluminium sulfide. Aluminium is here, sulfide. Al3 plus S2 minus gives us Al2S3. Iron 3 sulfate. Iron 3 sulfate gives us Fe3 plus SO4 2 minus. So like I said before, the easiest way to do this is to cross multiply, but if I just show you, we're going to have 6 positive charges and then 6 negative charges. So it's going to be Fe2 SO4 3. Iron 2 sulfate. Iron 2 sulfate, Fe2 plus SO4 2 minus FeSO4. Lead 2 sulfate, lead 2 sulfate, Pb2 plus SO4 2 minus PbSO4. Aluminium sulfate, aluminium sulfate, Al3 plus SO4 2 minus. So we need equal number of positive and negative charges, which gives Al2 SO4 3. Zinc sulfate, zinc sulfate, Zn2 plus SO4 2 minus ZnSO4. Barium sulfate, barium sulfate, Ba2 plus SO4 2 minus, 1-to-1 ratio, so we have BaSO4. Ammonium sulfate, NH4 plus SO4 2 minus is going to give us NH4 2SO4. Magnesium sulfate, Mg2 plus SO4 2 minus MgSO4. Lithium sulfate, Li plus SO4 2 minus is going to give us Li2SO4. Magnesium hydroxide, Mg2 plus OH minus MgOH2. Aluminium hydroxide, aluminium hydroxide, Al3 plus OH minus, AlOH3. Potassium hydroxide, potassium hydroxide, K plus, OH minus, KOH. Ammonium hydroxide, ammonium hydroxide. So we have NH4 plus and OH minus, 1 plus, 1 minus. We can put this together in a 1:1 ratio, making NH4OH. Barium hydroxide, barium hydroxide, Ba2 plus OH minus. We are going to need 2 hydroxides for every barium. Lithium hydroxide, Li plus OH minus. Nice 1:1 ratio going on there. Aluminium nitrate, aluminium nitrate, Al3 plus NO3 minus. So we are going to need 3 negative charges from the nitrate for every aluminium that we get. Ammonium nitrate, ammonium nitrate, we have NH4 plus NO3 minus. These can go together in a 1:1 ratio. Lead 2 nitrate, lead 2 nitrate, PB 2 plus NO3 minus. So we are going to need 2 nitrates for each lead. Sodium nitrate, Na plus NO3 minus, NaNO3. Lithium nitride, lithium nitride, Li plus N3 minus. So we're going to need 3 lithiums for every nitrogen. Magnesium nitride, Mg2 plus N3 minus. So we are going to need 3 magnesiums to make everything up to 6. So we're going to get Mg3N2.